Purushottam sir, live start.
Okay, sir.
Okay, good morning to all of you. Now we are in the probability topic. Already we have completed 3 classes and we are in the exercise, first exercise a little bit, some of the sums are completed in the first exercise. So now the remaining part will be discussed by our Purushottam sir today. Please go through the once again, you recollect your fundamental formulas, then you sir will go through the exercise questions. So Purushottam sir, please go through the concept.
Thank you, sir. Good morning to everyone. Children, screen sharing or sir? Sir, screen sharing out, sir. Okay. Children, welcome to 4th day on probability. Today we are going to do some more problems in exercise 13.2. I think children, you are practiced well on yesterday examples and exercise also. So children, today we discussed more problems on probability. Children here.
నేను అన్న సోనీ వినిపించుకోలేదు సోనీ ఏం చేస్తాను నేను
Children here, 5th one is there, that it is Rahim removes all hearts from the deck of hearts. Children, here is a problem. Rahim removes all hearts from the deck of cards. What is the probability of? Already first one yesterday we discussed. That's why I did it. The first one, getting a diamond. See children here, getting a diamond. Second one here, getting a card that it is not heart. That it is not heart. Getting the ace of hearts. Getting the ace of hearts. Okay, here, first of all, we read once again. The sum is Rahim removes all the hearts from the deck of hearts. What is the probability? Already we have some knowledge on playing cards. How many cards are there? How many sets are there? Okay. Using that one, we will do these problems. The first one is picking a diamond. Picking a diamond. So here, once again we recall the definition of probability. The definition of probability. Okay, children, tell me what is the definition? Classical definition: probability is number of favorable outcomes by total number of possible outcomes. Here, the number of favorable outcomes to diamonds. The number of favorable outcomes to diamonds. So here, children, here Rahim removes all hearts. Rahim removes all hearts. That's why here possible outcomes. Here we find possible outcomes. How many possible outcomes are there? How many hearts are there in a deck of cards? Yes, 30. So 52 minus 30 is 39 is our possible. 39 is our possible outcome. Here favorable outcomes are how many? The favorable outcomes how many? 30. Why? Because picking up a diamond. Picking up a diamond. That's why here the probability. The probability.
Purushottam sir, screen share అయినట్లేదు డిస్ప్లే.
షేర్ కాలేదు సార్.
స్క్రీన్ షేర్ కాలేదు చూడండి ఒకసారి. కంప్లీట్ మీరే కనిపిస్తుంది.
ఇప్పుడు ఓకే సార్.
ఓకే ఇప్పుడు నౌ ఇట్స్
ఓకే సార్ ఇప్పుడు. ఓకే సార్. Okay, children. Now, here, fifth one. Rahim removes all the hearts from the deck of cards. What is the probability? What is the probability? So here, the first one is getting a diamond. Getting a diamond. Getting a card that it is not heart. That it is not heart. Third one, getting the ace of hearts. Getting the ace of hearts. So here, already Rahim removes all hearts in a deck of cards. A deck of how many cards are there? Totally, we know that 52. Here he removes all the hearts, all the red heart cards. That's why how many remaining there? Yes, 52 minus 30 is equal to 39. That's why here number of favorable outcomes. Here number of favorable outcomes are how many here? 30. So total number of possible outcomes already we discussed. Total how many? 39. So here children, number of favorable outcomes to picking up a diamond is 13, and the total here possible, not possible outcomes are here not 52. Think why? Because already all hearts are removed from the deck of cards. That's why 39 cards are there. That's why here the possible outcomes are how many? Yes, 39. So here probability. The probability of picking a diamond is equal to number of favorable outcomes picking a diamond divided with total number of possible outcomes. Total number of possible outcomes. Okay, already P of diamond, P of D is equal. P of D is equal 39 by 13 by 39. Listen, see here carefully. 13 by 13. 13 is favorable. 13 is favorable. 39 is total number of possible outcomes. That's why 1 by 3. That's why here 1 by 3 is the probability. What is the probability of picking a diamond here? Picking a diamond is equal to is favorable outcomes by total number of possible outcomes. That's why 13 1 ja, 13 3 ja. So 1 by 3 is the probability of picking a diamond. Next one is here picking a card not heart. See here, see carefully children, picking a card which is not heart, That's why we know that here all odds are removed. Is already given. All odds are removed, and hence remaining all are not heart cards. See children here, already we remove all hearts cards. So remaining all are not hearts. Okay. So pick up the not heart card is a yes, sure event. That it is a sure event. That is a certain. That the card is sure, certain. That's why. So that the probability is. What is the probability of sure event? 1. Yes. Already another total number of possible favorable outcomes by total number of possible outcomes. That is total number of favorable outcomes. How many? 39. Possible outcomes also 39. 39 by 39. 39 by 39, which is 1. So we can also do like that, and this is we can do like this. Okay, so that the probability is picking a card not heart. Picking a card not heart. The probability of picking a card not heart is a sure event. That's why the probability is 1. Okay, children, please note down that one, children. Okay, next third one. Picking out the ace of hearts. Picking out the ace of hearts. Here, picking up the ace of hearts. So here solution is picking out the ace of hearts. Here, number of favorable outcomes. 0. Why? Why? Because all odds are removed from the deck of cards. All hearts are removed from the deck of cards. So that's why there is no ace of heart. Have understood? So there is no ace of heart. Totally ace are 4. Ace are 4. Spade, heart, diamond, club. So here all hearts are removed. Now here we want ace of heart. Ace of hearts. So there is no hearts. That's why there is no ace of hearts. There is no ace of hearts. So here favorable outcomes how many here? 0. Here 0. Why? Because all hearts are removed and hence it is impossible event. Okay, children. Already we discussed sure event. Already now this is impossible event. So P of picking the ace of heart is 0. We can also find like this. Here probability of picking up ace of heart is equal to number of favorable outcomes by total number of possible outcomes. Here number of favorable outcomes is 0 and total possible outcome 39. 0 by 39 is equal to 0. This is the another way to solve this problem. This is another way. This is also 0 is the impossible event. Impossible event. So that's why here picking out the ace of heart is 0. Okay. See children, this once again note down on your notebook, children. Now we move into another one, children. Okay, here seventh problem is there. Now I read carefully, listen children here. A die is rolled once. A die is rolled once. Find the probability of getting here. A die, already we know about the die. A die is nothing but a cube with six equal faces. Okay, faces 1, 2, 3. A numbering is there 1, 2, 3, 4, 5, 6. Okay. Now what? Next one is what? Getting a prime number. The first one is getting a prime number. Listen children carefully. A prime number. We find the probability of getting a prime number. Second one is what children here? Okay. A number lying between 2 and 6. A number lying between 2 and 6. Second one. And we move. Third one is what? An odd number. Third one is an odd number. So children here, now the solution of the sum is children here. Solution. When a die is thrown from one time, total number of outcomes. When a die is rolled or thrown. When a die is thrown or when a die is rolled only one time. What is the possible outcomes? What are the possible outcomes? The possible outcomes are, we know very well about that. What is 1, 2, 3, 4, 5, and 6. Okay, these are also sample space. These outcomes are how many here? 6. So here total possible outcomes are 6. And then now we find that it would be a prime number. So here we find a favorable outcomes. Here we find the favorable outcomes. Number of favorable outcomes. So here these all are possible outcomes. Among these we find a prime number. We find here a prime number. Already, what is the definition of prime number? Already we learned in our previous class. What is the prime number? A number which consists only 2 factors. That it must be 1 and or itself. 1 and or itself. So here 1 is not a prime number. 1 is not a prime number and also composite number. We know that. So here 2 is a prime number. 2 has two factors, only 1 and 2. 3 also a prime number. 3 has only two factors, 1 and 3. 4, 2 to the 4. This is not a prime number, is a composite number. So 5 is also a prime number. Why? Because it has only two factors, 1 and 5 itself. Okay, and 6 is not also prime number. Why? Because 2, 3 is 6. This is a composite number. So 2, 3, and 5. 2, 3, and 5 are prime numbers. 2, 3, and 2, 3, and 2, 3, and 5 are prime. That's why the favorable outcomes are how many here? 3. Favorable outcomes 3. The prime numbers are 2, 3, 5. So favorable outcomes is sample space here. Sample space. Favorable outcomes here 3. Okay. Now we move. So probability of getting a prime number. Probability of getting a prime number is, already once again we recall the probability definition. We recall the probability definition. Tell me children, this probability is number of favorable outcomes divided with the total number of possible outcomes, total number of outcomes. Already the number of outcomes are favorable outcomes are there. Total number of outcomes are there. So we substitute the values. We substitute the values. We get probability of prime number P. Simplify. Probability of prime number. Probability of P is equal to 3 by 6. 3 is what here? Favorable. The number 3 is favorable. Number 6 is what? Possible outcomes. Possible outcomes. Total outcomes. Total. That's why 3 1 ja, 3 2 ja. 3 1 ja 3, 3 2 ja. Is a 1 by 2. Means here 50%. So getting the probability of getting a prime number. The probability of getting a prime number is what here? 1 by 2. Okay. Have understood children? 1 by 2. Next one. See children here. Second one is what here? A number lying between 2 and 6. We find the probability of, we find here the probability of a number lying between 2 and 6. 2 and 6. Okay, now here we find the number of favorable outcomes. So total already possible outcomes are 1, 2, 3, 4, 5, 6. Among these, we want here 2 and 6. The number lying between 2 and 6. 2 above, 6 below. 2 above, 6 below. That's why here, how many favorable outcomes? 3, 4, 5. How many outcomes? 3. Which are 3, 4, 5. So favorable outcomes are here 3. How many favorable outcomes? 3. So next. So the probability of getting a number between 2 and 6. Okay. The probability of getting a number between 2 and 6. Once again, we recall the probability definition. The probability definition. What is the probability definition? Probability. Number of favorable outcomes 2. A number lying between 2 and 6 divided by total number of outcomes. Total number of outcomes. Okay, children. Already. Yes. P of E. Even. We'll here E even. Even means here number lying between 2 and 6. So P of E is equal to 3 by 6. Think why? 3 here favorable. 6 here total. So 3 by 6. 3 by 6. When we substitute these values, favorable outcomes and the total number of outcomes, 3 by 6. Here also 3 1 ja, 3 2 ja, 1 by 2. We get the answer is 1 by 2. We get the answer is 1 by 2. So children, before a prime number is 1 by 2, a number lying between 2 and 6 also 1 by 2, 50%. Now we move next one. Children here, third one is an odd number. Third one is an odd number. So odd numbers, we already discussed odd numbers and even numbers in a 6th class or in 4th class also. Odd number. What is the odd number? a number is divided with 2, the remainder is 1. If remainder is 0, those all are even numbers. If remainder is 1, those all numbers are odd numbers. Here, total possible how many already we discussed. Total possible how many? 1, 2, 3, 4, 5, 6. That's why which is a die. This is a die. That's why 6 possible. 6 possible. Total outcomes are possible or total of how many? 6. Here now we find favorable outcomes. Odd numbers among 6. 1, 2, 3, 4, 5, 6. Here favorable outcomes how many? 3. Favorable outcomes 3. What are they? They are 1 is odd number. 2 is not odd number. Why? Because 2 is a even number. 1, 3, 5 odd number. 1, 3, 5 odd number. Why? Because we divide with 2. These are the remainder is 1. That's why it is a odd number. Already we find prime number. Here odd even numbers. See children the difference. Here prime number. Previous prime number. Now we odd number. We here odd number. So favorable outcomes how many? 3. Favorable outcomes how many? 3. So here 1, 3, 5 odd numbers. Now the probability of getting an odd number. The probability of getting an odd number. Hey children, once again we discuss. We recall the probability definition. Probability definition. This is a very important. Already I told you past. Probability definition is very important. Using this probability definition, the total number of total problems we solved using this. So probability is equal to number of favorable outcomes. Number of favorable outcomes divided with the total number of outcomes. Divided with the total number of outcomes. That's why. So children, here. Now, what is the favorable outcomes? Favorable outcomes are 3. Favorable outcomes are 3. And the total number of outcomes 6. So P of an odd number is equal to 3 by 6. 3 1 ja, 3 2 ja. 1 by 2. 1 by 2 is the final answer. So 3 questions are same. 1 by 2, 1 by 2, 1 by 2. Odd number, the probability of odd number, the probability of prime number, the probability between 2 and 6. So using this, we create so many problems. We create so many problems. So see children, try children, you create some problems and you solve them. Okay. So here the probability an odd number is what? 1 by 2. The probability of the odd number is 1 by 2. Now we move into another one. Children, I will give you a task for you, children. Make 5 more problems of this kind of using dice, cards, or birthdays, and discuss with friends and teachers about their solution. See children, here you may try to create some more problems using dice, cards, birthdays. Okay, discuss with your friends, and if any doubts, ask your subject teacher. Then you can thoroughly on these problems. Okay, you can solve easily. So try children. This is a task for you. Is that make 5 more problems. In dice 5 problems, and on cards 5 problems. Not 5. If you interested, 5 and more problems. Okay, children, right? Do that one. Okay, write down children this. And now another some more applications on problem. Children, some more applications. Now we shall see some more applications. So children, here one of the example is there. See, listen carefully. A box contains 3 blue, 2 white, and 4 red marbles. Do you know marbles? Like a stone. The marbles here, marbles, more stone. If a marble is selected at random, if a marble is selected at random from the box, what is the probability that it will be? Once again, I will read it. A box contains 3 blue balls. How many blue balls? 3 blue balls. 2 white. How many white? 2 white. And how many red balls? How many red marbles? 4 red marbles. Here marbles. 3 blue marbles, 2 white marbles, 4 red marbles. We use these as a balls also. Okay, whatever. Another problem created. Okay, 3 blue marbles, 2 white marbles, 4 red marbles. 4 red marbles. If a marble is selected, if a marble is selected at random, if a marble is pick up, if a marble pick up, selected a random from the box, what is the probability that it will be? Number 1, white, that it will be a white, the probability of the white. Now, second one, blue, third one, red, white, blue, red. Now we see solution that it will be white, the probability of that it will be white, will be white. So here, see children, here marble is drawn at random means all the marbles equally likely to be drawn. All the marbles equally to be drawn here equally likely. Drawn is here, all are equally likely. So here, now here the number of possible outcomes. Here, first of all, for every problem we find all possible outcomes and favorable outcomes. Why? Because the formula is there. So that's why here the number of possible outcomes. What is the number of all marbles? 3 plus 2 plus 4. Total how many? 3 plus 2, 5, 5 plus 4, 9. 9 is the total outcome. The number 9 is total outcome. Now, see children here, let W denote the event the marble is white. Okay, W is white. Why? Because of W, the first letter W. B denotes blue. And R denotes red marble. So here we take W, D, R. Why? Because why? W means white marble, B means blue marble, R means red marble. And next, so here the number of favorable outcomes to white already in the problem given. This is given, already given. The white marbles, how many? Only 2. White marbles are 2. That's why has favorable. That's why here favorable outcomes are how many here? 2. Only 2. Now, yes, already our formula probability is equal to number of favorable outcomes divided with the total number of outcomes. Okay, probability. This is the probability formula. Now we substitute the number in that formula. So P of white. Here P of white. Favorable outcomes how many? Yes, 2. Total numbers already 3 plus 2 plus 4. Okay, 2 by 9. 2 by 9. That's why here 2 by 9 is the probability of getting white marble. Probability of getting white marble. What is the probability of getting white marble? 2 by 9. It's a very easy. 2 by 9. And then next, similarly, we find the probability of blue. Similarly, probability of blue. Probability. How many favorable to blue? How many favorable? No problem. It already is there. Given. What is 3? The blue marbles are 3. 3 by 9 is a favorable outcomes by total number of outcomes. The favorable outcomes, total number of outcomes. 3 by 9. 3 by 9 means 3 1 is 3 3 is a short form. 3 by 9 short form is 1 by 3. P of white, probability of white is equal to 2 by 9. Probability of blue is equal to 3 by 9. This short form is 1 by 3. Now, to find the probability of red, and P of red is equal to P of red. Favorable. How many is favorable to red? How many is favorable to red? Yes, 4. How many is favorable to red? 4. Total how many? 9. 4 by 9. Probability of white is 2 by 9. Probability of blue is 3 by 9 or 1 by 3. Probability of red is 4 by now. So here we notice one thing here is note that here P of W plus P of blue plus P of red. P of W plus P of blue plus P of red is equal to here probability of white 2 by 9, probability of blue 3 by 9 or 1 by 3, 3 by 9. Why? Because all are like 5, we take 9 like 5, 3 by 9. Here probability of red 4 by 9. Here we add these all marble probability, white marble probability, blue marble probability, red marble probability. So all marble probability are there. So sum of, so here P of W plus probability of white, probability of blue plus probability of red, 2 by 9 plus 3 by 9 is what here? Here 2 plus 3, 5, 5 plus 4, 9, 9 by 9. Already we discussed. What we discussed here? The sum of the probabilities, of all elementary events is 1. The sum of the probabilities of the elementary events is what? The sum of the probabilities of all events is 1. So that's why 9 by 9 is equal to what? 9 by 9 is equal to, and also we also discussed the probability is less than or equal to 0, greater than or equal to 0, and less than or equal to 1. The probability between 0 and 1, which is equal to 0 or equal to 1. So 0 is less than or 0 is less than or equal to 1, less than or equal to. Okay, the probability between 0 and 1, which is probably equal to sometimes 0 and equal to 1. 0 is less than or equal to 1. P of is less than or equal to 1. Already we learned about that. So here, next one. Example. See children here, Harpreet tosses 2 different coins. Is another kind of problem which is related to coins. Harpreet tosses 2 different coins simultaneously. He tosses 2 different coins. Say one is 1 rupee, another one is 2 rupee coin. What is the probability that she gets at least 1 head? So here, see example here. Harpreet tosses 2 different coins simultaneously. She tosses 2 different coins. The 1 rupee and another 2 rupee. What is the probability that she gets at least 1 head? That she must 1 head. Must 1 head. First we find out what we have children. Yes, here, see. So here we write H for head. H for head and T for tail. T for tail. When 2 coins are tossed simultaneously, when 2 coins are tossed, the number of possible outcomes. Here, if 1 time tossed, number of possible 2. H comma T. Here 2 coins are there. 2 coins are there. How many possible outcomes are there? H. The first 1 rupee coin, H, 2 rupees coin, H. And in this 1 rupee coin H, 2 rupees coin, it may be tail. In 1 rupee coin T, 2 rupees coin, head. And TT, both are TT. That's why here 4 possible outcomes are there. When we toss a coin, how many possible 2 coins? When we toss a 2 coins here, when we toss 1 coin, 2 possible. When we toss 2 coins, how many? 4. If 3 coins, think how many? Yes, 8. Here 4. The possible outcomes are how many here? 4, which are all equally likely. Here HH means heads on the first kind, 1 rupee, and also heads on the second kind, 2 rupees. Similarly, HT means heads up on the first kind and tail up on the second kind, and so on and so on. So here the possible outcomes are HH, HT, TH, TT. HH, HT, TH, T. Total outcomes. Here the possible outcomes. Here we find possible outcomes are 4. We find favorable outcomes. Here outcomes favor to E. Yes. One head must. Among 4, one head must. Here outcomes favorable to event E, at least one head. Here already 2 heads. Here one head is there. Here one head is there. Here no head. So the favorable are HH, HT and TH. So favorable outcomes are how many children? 3. Possible how many? 4. Possible 4. Favorable 3. Because at least one head. Here we want at least one head. So 3 favorable outcomes. 3 favorable outcomes. Those are HH, HT and TH. So the number of outcomes favorable to E is 3. Okay, 3. Okay, already favorable is there, favorable is there, possible is there, favorable and total. So probability of the probability definition, favorable outcomes divided with the total number of possible outcomes. That's why here 3 by 4. 3 is favorable, 4 is possible. 4 is possible, 3 by 4. Since the total possible outcomes 4. So that is the probability that Harpreet gets at least one head is 3 by 4. And that means 75% of chances. 75%. 75%. Okay, here have you understood, children? Next. Here, that is here another one is there. Another kind of problem. 2 dice, 1 red and 1 yellow are thrown at the same time. Write down all possible outcomes. What is the probability that the sum of 2 numbers appearing on the top of the dice is 8? Number 1 is 8. Number 2 is 13. Number 3 less than or equal to 12. Okay, we may solve this one. 2 dice here. In before 2 kinds. Here 2 dice. One is red, another one is yellow. 2 dice. If you have 1 die, the possible are 6. Here 2 dice. So we find how many possible outcomes are there. So here 2 dice. One is red, another one is yellow. When the red dice shows 1, the yellow dice could show any one of the number 1, 2, 3, 4, 5, 6. The same is true when the red dice shows 2, 3, 4, 5 or 6. The possible outcomes of the experiment are shown in the figure like this. When we roll 2 dice, on the top is 1, 1. It may 1, 1. It may 1, 2. It may 1, 3. It may 1 is red. Here 1 is yellow. Here this one is red. 2 is yellow. Like this. So total 1, 1, 1, 2, 1, 3 is total. How many possible outcomes? 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 6, 6, yes, 6, 6, 36 possible outcomes are there. 36 possible outcomes there. Why? Because if we toss 2 coins, 4 possible outcomes. Here we take 2 dice. Here we take 2 dice. The possible outcomes are how many? 36. So note that the pair 1, 4 is a different from 4, 1. Already we know that. So the number of possible outcomes. 1 here means red, 4 means here yellow. Here 4, 1, 4 means here red, 1 means yellow. That's why it's a different. 1, 4, 4, 1 is different. Okay. So the number of possible outcomes, number of total sample space, number of total possible outcomes are 36. Total possible 36. So here the outcomes favorable to even, the sum of the two numbers is 8. The first one is the sum of the two numbers is 8, denoted by E R. So here we find here 2 6, 2 plus 6 8 is the one favorable. 3 plus 5 8, 4 plus 4 8, 5 plus 3 8, 6 plus 2 8. See figure. Okay. So that is number of outcomes favorable to E. Number of E is equal to how many here? 5. Why? Because here only we want the sum of the two numbers is 8. First one we take 1 1 1 1 2 is not favor. 1 2 1 2 3 is not favor. We want only the sum of two numbers is 8. Those are 2 6 3 5 4 4 5 3 6 2. Okay. How many favorable? 5 only. Number of favorable outcomes of 5. That's why already P of E, probability of event, probability of an event is equal. What's the number of E by number of S? Number of means favorable outcomes. Number of favorable outcomes by number of possible outcomes. Favorable 5 here, 5 here favorable. 36 here, 36 possible. That's why 5 by 36 is the sharp one. Okay, the 5 by 36. So here the probability of the getting sum of the two numbers is 8 is 5 by 36. 5 by 36. Next is the second one. See children here, as there is no outcome favorable to event F, the sum of the number is 13. Here sum of the number, here sum of the number 8, here sum of the number is 13. In any 1 plus 1 2, last 6 plus 6 12. So here the sum of the any two numbers not 13. Why? Because 6 plus 12 is the highest. 12 is sum of 2, is here 12 is the, that's why there is no outcomes. There is no outcome. So the P of E is equal to 0. There is no outcomes, 0. No outcomes are there. It is not possible. This is not, the sum of the two numbers is 13 is not possible. Okay. So 0 by 36. 0 by 36 is 0. So the probability of the sum of the two numbers is 13 is impossible. That event is impossible event. The probability is 0. That is impossible event. Okay, children. Now third one. As all the outcomes are favorable to event G, what is the sum of two numbers is 12 and below. Sum of two numbers is 12 and below is what? Here all outcomes are favorable. Below here 2 and below, 12 and below 12. Already in the problem is given. So that P of G is equal to 36 by the sum of here. From is there. Sum of two numbers is 12 and less than 12 here. Less than 12 already in the problem. So 36 by 36 is 1. 36 by 36 is 1. Well, so you find only 12. The sum of you find 12. How many? Try. 5 children. The sum of two numbers is 12. Try. Here the sum of two numbers 12 are below. This is not. Okay. Now we move into exercise 13 children. The first one is a bag contains 3 red balls and 5 black balls. A ball is selected at random from the bag. What is the probability that the ball is selected is? Okay, children. Here the first one is the bag contains 3 red balls. How many red balls? 3 red balls and 5 black balls. 5 black balls. A ball is selected at randomly from the bag. What is the probability that the ball is selected is? Okay, see. Number 1 is it should be red and it should not red. That it will be red or not red. So now we move solution. So here, first of all, we want to find the total number of possible outcomes. Total number of balls in the bag means number of total outcomes. 3 red plus 5 black. Total how many? 8. Total how many? 8. So total outcomes are 8. Now, here, the first one is what here? First one is red. The probability of getting a red, is what here? Number of favorable outcomes to red is 3. Already 3 red balls. That's why we take favorable 3. And now the probability definition is there. The probability. What is the probability definition? Number of favorable outcomes divided with total number of outcomes. The very important formula throughout the chapter. The probability. Classical definition. So here the probability of getting red. Probability of getting red is what here? P of R is possible, favorable 3, possible 8. 3 by 8. Simple is the answer. Probability of getting red, P of R is equal to 3 by 8. Now, next one, solution. Next one, probability of not red. So here P of not red. P of not red. Here your bar is there. P of not, P of, or P of E plus P of not E, like that. P of not R. P of not R, not red. Then P of R plus P of not R is equal to 1. We know that. We take into P of E plus P of complementary events. P of E plus P of not is equal to 1. That's why here P of R plus P of not R is equal to 1. We find P of not red. Take this side 1 minus P of R. 1 minus P of R. 1 minus P of R. Here 1 minus P of R. Probability getting red is what here? 3 by 8. 1 minus 3 by 8. It will change into like fractions. 8 by 8. 8 minus 3. 5 by 8. 1 is 8 by 8. 8 minus 3. 5 by 8. So here the probability of getting red is 3 by 8, and the probability of getting not red. The probability of getting not red is 5 by 8. 5 by 8. Okay, have understood, children? It's a very, very important problem. Okay, we may see in annual examination also. So write down these problems, children. Next, we move third one, children. We move into third one. A kidney bank contains 150 pies, coins, 50 1 rupee coins, 20 2 rupee coins, and 10 5 rupee coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin? First of all, we try to 1. A kidney bank is there. Kidney. We have kidney bank. So will be a 50 pies coin. Will be a 50 pies coin. So here, children, first of all, now 1 will be a 50 pies coin. So total number of 50 pies coin here 100. Number of 1 rupee coin 50. Number of 2 rupee coin 20. Number of 1 rupee coin 10. Total number of possible outcomes is 180. So the total number of outcomes for a coin fall down is 180. Now we will find will be a 50 pies a coin. Will be a 50 pies coin. Now, children, here number of favorable outcomes to a 50 pies coin. How many, children? Yes, 100. Why? Because 100 is 50 pies coin is there. We may drop into 50. It is a possible 100 times. 100 favorable to 50 pies coin. So probability is given. That is the probability definition. Number of favorable outcomes by total number of outcomes. For total number of outcomes. So probability of 50 pies coin is equal 100 by 180. 100 by 180. So 0 0 cancel. 10 by 18. 2 5s are 2 9s are. 2 5s are 2 9s are. So this 5 by 9. 5 by 9 is the probability of getting 50 pies coin. Probability of will drop already. So the probability of 50 pies coin is how many? How much? 5 by 9. 5 by 9 is the probability. So children here, please try remaining problems. So using here the key formula is what here? Probability formula. Number of favorable outcomes, number of possible outcomes. Throughout the chapter, we may use this formula only. If we read the problem with, we easily solve the problem. Okay, we read the problem, we easily understood. Okay, what are the favorable and what total possible, how many. Simply we substitute in the formula we get. So children, this is our 4th day's end of the class, and children, tomorrow we will continue, okay, with new sums on exercise 13.2. You may do some more problems also. This chapter is very easy, children. That totally depends upon the probability formula. Okay, children. If any doubts, please ask your subject teacher. Okay, I will complete tomorrow with some more problems. Have a nice day, children. Thank you.
Thank you very much, Purushottam sir. The end of the 4th day of our probability. Most probably tomorrow is the last class for the probability. After that, we will plan for the another topic which was not covered in our syllabus. Already we have completed this 13th topic. We have already finishing this live streaming classes here tomorrow at 9 o'clock. This is the progress of signing out from the YouTube channel. This is the second for the technical team who supported for the online live streaming classes. Thank you very much.